Hello everyone! In today's video I would like to review OSPF Virtual Links and Discontiguous Networks. But before we begin, I would like to ask you to subscribe to my channel with notification bell on and please show your support by hitting like button. So let's talk about it. So what are discontiguous networks? Let's review this example. In our example, routes traffic from area 24 to get into area 35 need to cross non-backbone area 1 to 3. So networks are discontiguous if inter-area traffic needs to cross non-backbone area. And in this case, because of logic how ABRs work, router R4 doesn't have routes into networks 3.3 and 3.5. See, it has only networks in routing table 10, 12, 10, 13, 10, 22, 12, 13, 22. R2 has 13, 3335, 13, 3335, good. R1 has 24, 22, 3335, 24, 22, 3335. R3 has 12, 22, 24, and again R5 has only 12, 13 and 33. Again, doesn't know anything about area 2 or area 0, sorry, on router R2 and area 24. So this happens because again of the logic of ABRs, which are routers connected to at least two areas, one of which is a backbone area. So the logic of how ABRs create type 3 LSAs. So first rule, and this is my understanding, how I understand this first rule. Type 1 LSA, if you know something different, you can leave your comments and we will discuss it. But my understanding, type 1 LSAs received from an area create type 3 LSAs into backbone area and non-backbone areas. So when ABR receives type 1 LSA, it creates type 3 LSA into backbone area, and when ABR receives type 1 LSAs from a backbone area, it creates type 3 LSA into non-backbone area. Second one, type 3 LSAs received from area 0 are created for the non-backbone area. When ABR receives type 3 LSA, it creates type 3 LSA into area. For example, here from area 0, let's say when it receives type 3 LSA from area 0, it creates type 3 LSA into area 24, and here in area 1 to 3. And the last one, type 3 LSAs received from a non-backbone area are only inserted into the LSDB of the source area. ABRs do not create a type 3 LSA for the other areas, including a segmented area 0. When ABR receives type 3 LSA from a non-backbone area, it only inserts it into the LSDB of the source area on itself. And ABR does not create a type 3 LSA for other areas. So in this case, it needs to send it to area 0 to create type 3 LSA. But because of these three rules, these routers, they are not getting LSAs for these areas, so they don't know anything about this. To fix this issue with discontiguous network, first we can change area 1 to 3 to area 0. But if it is not the case, we can use virtual links. So let's just quickly review this discontiguous network in example. We have area 24, we have area 1 to 3, we have area 35, and we have a loopback interface on router R3 in area 0 and loopback interface on R2 in area 0. Let's see. Show IP OSPF interface brief. So we have loopback interface in area 0. G01 in area 24, G00 area 123, and the same for R3. So IP OSPF interface brief. We have loopback interface in area 0, G01 area 35, G00 area 123. Let's see routes. Show IP route OSPF. This is our R1. As I said, it has only 1012, 1013, 1022. Show IP OSPF database. It has LSA type 1 for link ID 22, for router R2, R4, netlink states, and summary netlinks, summary LSA or type 3 LSA for networks 10, 12, 1013, and 1022. The same what they have, it has in routing table. The same is for R5. So IP route OSPF 12.13.3.3. show IP OSPF database. As you can see, we have type 3 LSAs only for 10.12, 10.13, and 10.33. So what I mentioned, virtual links can be used to fix these problems with discontiguous networks. Which cases virtual links can be used as well? So first, when linking an area that does not have a physical connection to the backbone. This is our case, for example. We have area 0 and area 34 does not have physical connection to the backbone area. So in this case, we probably need to create virtual link for this area 34 to get into area 0. Or second one, patching the backbone in case discontinuity of area 0 occurs. This is our example. In this case, we need to create virtual link. Or as I mentioned, we can convert this area 1 to 3 in area 0, but this is not our case. We can create a virtual link, or there is one more example like this, and because we have here discontinuity in area 0, we also need to create a virtual link. Let's review some information about virtual links. First, we can consider virtual link like kind of virtual tunnel within OSPF between an ABR and another multi-area OSPF router. For example, in this case, this router is ABR because as per RFC 3509, a router is considered to be an ABR if it has more than one area actively attached and one of them is the backbone area. So in this case, router R2 has two areas attached, area 0, area 23, and area 0 is backbone area. But router R3 is not ABR because it has two areas attached, but none of them is ABR. So in this case, this one we need to run virtual link between ABR and multi-area router. But in this case, yes, we have two ABRs, R2 and R3, and we need to run a virtual link between them. Next information or fact is that virtual links should not be used as a primary backbone design feature. They can be used as a temporary solution in case there is a failure or some other issues, but never like a primary backbone design feature. Next, that virtual links cannot go through more than one area. If you need to connect area through two areas, you need to create two virtual links. This is for these two facts or pieces of information. That, for example, we have a configuration like this. We have area 0, we have area 2, 3, 3, 4, and 4, 5. So we create one virtual link between R3, R2. R3 gets connected to area 0, and then we create a virtual link for between R3 and R4, and then everything is okay for area 45 as well. Virtual links can only run through standard non-backbone areas, and virtual link cannot run also through stub areas. Hello protocol works the same over virtual link. For example, it has default hello timer 10 over virtual link. But LSAs learned through virtual link have the do not age option set so that the LSA does not age out. This is done to prevent flooding of a virtual link. And the last one, virtual links are built between routers in the same area. This area is called transit area. And router terminating virtual link becomes an ABR if it doesn't have already interface associated in area 0. So as I mentioned a little bit earlier, if this router which terminate virtual link is not ABR, it becomes ABR because it gets interface, virtual interface associated with area 0. So let's review our previous networks and how they're gonna look with virtual links. First, linking an area that doesn't have a physical connection to the backbone. In that case, we create virtual link between router R3 and R2, and then router R3 will create virtual interface connected to area 0. It becomes also ABR, and then area 3 is not going to have any problems anymore. Second one, patching the backbone area in case discontinuity of area 0 occurs. For this design, we create virtual link between R2 and R3, which are in the same area 1, 2, 3. And then we are not going to have problem for routers R5 and R4. We will see this in the configuration example. And the second one for this, in this case, we create virtual link between R1, R2, and we are not going to have discontinuity anymore. So everything is fine with area 0. So how to configure virtual link? To do this, you need to use command under the OSPF configuration mode, area ID, virtual link, endpoint router ID. So in this case, area ID is the area ID of the transit area or the area through which your virtual link runs, let's say. And endpoint router ID is router ID of the virtual link neighbor. So the neighbor to this router to which you connect your virtual link. To verify the virtual link status, use the following command: show IP OSPF Virtual Links, and then you will see in the output that there is virtual link created to router 3333, do not age LSA allowed, transit area through which this virtual link goes, from which interface, cost, also state point to point, and default timers, as I said, default hello timer 10 seconds, dead timer 40 seconds. And virtual links appear as a specific interface. If you do show IP OSPF interface brief, you will see that virtual link shows up as a VL0 interface with area 0. And the virtual links routers form a point-to-point adjacency. For example, in this case, this router forms point-to-point adjacency with router R3. If you do show IP OSPF neighbors with R2, you will see that it has neighbor adjacency with router 3 and on interface virtual link 1. So let's do configuration example. We have same network, area 24, area 123, area 35, and the loopback interface on R2 in area 0 and loopback interface on R3 in area 0. Let's just double check. Show IP OSPF, no, show route OSPF. So as you can see, we don't have routes into area 35 where network is 1035 and to area 0 on R3 where network is 1033. Ping, let's say 103503, unreachable. Then show IP OSPF interface brief. Okay, we have interface in area 24. Let's go to our router, which is ABR. Show IP OSPF interface brief. So you can see loopback interface area 0, G01 area 24, G00 area 123. And show IP route OSPF. So here is good. And let's go to R3. Show IP OSPF interface brief. You can see loopback interface area 0, G01, G00. And also show IP OSPF database on router R4. Let's see. We have type 3 LSA for network 12, 13, and 22. So let's configure virtual link. Conf T router OSPF under router configuration mode area, and then it goes transit area, which is 1, 2, 3, and then we have keyword virtual link, and then we need to enter neighboring router. For this R2, neighboring router is R3, to which we're gonna run our virtual link. Okay, and then let's go to router R3, conf T router OSPF 100, area 123, virtual link, and then our 222 router. And then let's see. Show IP OSPF virtual links. So as you can see, we have virtual link OSPF VL0 to router 33. Do not HLSA allowed. Transit area 123 via interface G00. Cost, timers, show IP interface, show IP OSPF interface brief. So as you see, I have now additional VL0 interface to this router R3 for our virtual link, and this is point to point. Show IP OSPF neighbors, and now you can see that I have neighbor adjacency with router R3, and on router R3 same, show IP OSPF neighbors. I have adjacency with router R2, show IP OSPF interface brief, additional interface, and let's see what we have on router R4 now. And now you can see that we got two additional type 3 LSAs which we were missing for network 3.3 and 3.5. We didn't have them here. And let's see, show IP route OSPF. And now we have these two routes to these two networks here on network 35 and loopback interface network 10.3.3. Let's just try 10 ping 10.35.03, and this is successful. This is everything I wanted to show you for virtual links and discontiguous networks. Thank you very much for your attention. Here you can see some references that I used during preparation. Thank you very much for watching my video. I hope you enjoyed it. Please don't forget to subscribe to my channel with the notification bell on and show your support by hitting like button. I hope to see you soon in my next videos, but for now just goodbye and see you soon.